Yeah, good morning everyone. Today we will learn about the intelligent transport system. Nowadays, to reduce urban traffic congestion and to improve the road traffic efficiency, we cannot extend our roads, already available infrastructure, but we cannot extend it, we cannot widen the already available roads. So, there is a definitely need of intelligent transport system. Nowadays, this intelligent transport system plays a very important role in our modern life, which is used to reduce some unexpected events like accidents, and this is possible with the help of wireless communication technology in the vehicles. And today, means nowadays, the manufacturers agreed to produce the vehicles with the wireless equipment so that the vehicles can communicate with each other, and this communication can be possible in two different ways, and that are vehicle to vehicle communication and a roadside unit to vehicle communication. Here, two vehicles can communicate with each other to share their information regarding the turnings and their movements. And RSU to vehicle communication means here the roadside unit it can give the information to every vehicle, and the vehicle gets the information like if there is any congestion on the road or any accident happened on that road, etc. Next, some services of vehicle to vehicle communication are collision warning. It is like post crash and pre crash warnings. After any collision happen, collision means any accident happened, immediately that information is passed to the another vehicle. And blind spot or merge warning. If our vehicle is moving towards a blind spot, means we cannot see the turnings. Um, and merge warnings means we are going to combine with the some other lane. That warning is priorly given to the vehicle, and this current vehicle will pass the warning to the next vehicle, means coming behind the vehicle. And do not pass warnings and lane change warnings, emergency electronic brake lights. Suppose if there is any obstacle in front of a particular vehicle, then sudden brakes can happen. To take the sudden brakes, the vehicle gives a warning, and it gives an assistance like intersection movement and left turn, cooperative merging, and etc. And some services are provided by the roadside unit to the vehicle. And here the roadside unit gives the information to the vehicle like to reduce the speed. It's recording some work zone warnings or some school zone warnings, and some pedestrian in signalized crosswalk warnings, and curve speed warnings. If while traveling, if there is any curve in front of us, then we have to reduce the speed. No, that warning is given by the roadside unit to the particular vehicle. Then stop sign gap assistance, in front of us if there is any stop sign in a particular distance, it gives a prior warning to us. Then traffic signal violation warning, if you are going to violate the traffic signal, then it gives a warning to us. The roadside unit sends a warning to the vehicle. Then the challenges in the intelligent transport system. Nowadays, the main challenge is to reduce the traffic congestion. So, as a global economy is increasing, every individual person is buying their own vehicle, and this leads to the congestion on the road. How to reduce this congestion? So as of now we cannot widen the roads, but the one of the possible solution is to use the intelligent transport system or autonomous vehicles, because we cannot predict the human brains. So it the use of the autonomous vehicles can reduce the congestion. And next, reducing traffic accidents. Automatic incident detection systems means if anything happens on the road, that should be automatically detected, and the information can be sent to the nearest emergency services, and to improve the accident survival, etc. And here, coming to the traffic congestion, this traffic congestion causes lot of loss to our environment. Like if you are stuck in a particular area, if you are in the traffic, then every vehicle consumes a lot of fuel, and it generates a noise, and which causes a pollution in the environment. So this is a basic topmost problem nowadays every common person is facing. To avoid this traffic congestion, the possible solution is for the traffic flow modeling by using the autonomous vehicles. So we'll see what is the traffic flow, what are the different types of traffic flow modeling. So the traffic flow modeling helps us to control the congestion, and traffic flow can be modeled in three different levels: microscopic, macroscopic, and mesoscopic. Microscopic is nothing but here the communication between the two vehicles, one to one vehicle communication, so that the two vehicles can travel to their destination. And macroscopic is nothing but it is regarding a particular region. If you are modeling a traffic flow for a particular region, we call it as a macroscopic. Then mesoscopic means if you are modeling a traffic flow for a particular continent, for a country, then we call it as a mesoscopic traffic flow. And different traffic flow models, these traffic flow models can be implemented by using two different methodologies. One is the partial differential equations, and these partial differential equations depends on the mathematical calculations, and it is mostly used for continuous flow modelings. But coming to our traffic flow modeling, it is a discrete model, and discrete in space and discrete in time. So always it's better to use the cellular automata. And the cellular automata is a algorithmic model, and it is very feasible to implement also. Next, we'll see what is the cellular automata. The cellular automata is originally introduced by von Neumann and Ulam for the biological systems. There was a lot of research done on the cellular automata in our biological systems, and here every cell state changes as a function of time. For every second the cell state will change according to the set of rules that are given to a state depending on the neighboring of the cells. Every cell state changes depending on the status of its neighboring cells. And updating rule involves the neighborhood values of the just previous time step, and it is referred as a local rule. If the updating rule depends on the involvement of the neighboring values of the previous two time steps, then we call it as a second order rule. These all updating rules beyond the second order rules are called higher order rules. Then one-dimensional cellular automata. The cellular automata can be available in one-dimensional, two-dimensional, and three-dimensional, etc. So first we'll see about the one-dimensional cellular automata. So it is a coming to the intelligent transport system. One-dimensional cellular automata can be used for a single lane road with a two-way traffic flow. A one-dimensional NRA valued cellular automata, it consists of a 1D array of cells as shown in the picture. See, the traffic can be flow in two different ways. In the middle, there our current vehicle is present, that is I, and at the behind there I plus one location, another vehicle is there, and I minus one location, another vehicle is there. And it's a Boolean function, and every cellular automata depends on its own rules. For example, if we consider the Boolean function, the ith location vehicle depends on the movement of I minus 1th location vehicle and I plus 1th location vehicle. Here, for example, I have given some Boolean functions for the one-dimensional cellular automata. So this is psi I of t plus 1 equal to psi I of t xor psi I plus 1 of t. So here we are going to get the location of ith vehicle in the next time step, that is t plus 1. Depends on the location of current location and its next time step, next location. And next, two-dimensional cellular automata. The traffic flow is one-dimensional, but the in combination of multiple roads forms a two-dimensional array of cells. So two-dimensional cellular automata could be used to model the real-time traffic flow. So here, if you observe in this diagram, we have two different types of two-dimensional cellular automata. 5 neighborhood, 9 neighborhood cellular automata. If our current vehicle is at the location I comma j, then its state in the next time step depends on its surrounding vehicles, like I minus 1 comma jth position, I comma j plus 1th position, I plus 1 comma j, then I comma j minus 1th position vehicle. And the same like we have a 9 neighborhood cellular automata. So by using this cellular automata, we can construct a total of n power r local rules for a R neighborhood n-ary value two-dimensional cellular automata.